Hello, my name is Ryan Oberfrank from the team 14615 Turbocharged. Today I'm going to be showing how to import and create parts in OnShape. The part I'm going to be making today is going to be a gearbox. Of course, as always, we're going to start out by making one simple sketch. We're going to sketch onto the front plane, and then we're going to need to disable the top, front, and right planes, so we have a clear view of what we are making. We're going to bring it around to the front, and we're going to sketch out a rectangle. We're going to take our dimension tool and we're going to change the sides to 5 inches and 3 inches. This is going to be the standard plate that we're going to start working with. Once you're done with the sketch, we're going to go up into the top corner next to the sketch option, and we're going to extrude the plate. We're going to make it 0.15 inches, or actually 0.2 inches, just for some strength. Next, we're going to go to the front side and sketch out a hole onto the front. We're going to do this in the form of a circle that is aligned with the center of the plate. We're going to change the center of the hole 1 inch from the side, and we're going to go over to the next tab. This is the Neverest Orbital 20 gear motor that we're going to be working with. We're going to download the CAD file here, as seen as a step file, and we're going to import it in OnShape so we can measure out the dimensions and base our hole around them. We're going to go under the Create menu and we're going to click Upload File, or Import File, and we're going to import our step file. Once that is done loading, it'll appear as a new part in the menu. We're going to open it up and see what is in it. Now that we're done importing the motor, we're going to take the measurement of the top ring to be able to make the hole in the gearbox plate. It measures at a radius of 0.33, but just to be able to make sure that we are getting the correct measurement, we're going to create a sketch and put a circle at the center point. And it is 0.866 as the diameter. So we're going to go back to our gearbox plate, we're going to edit sketch 2, and we're going to use our dimension tool to be able to make that 0.87. Alright, now that we've done that, we're going to finish this sketch, and we are still missing the shape that the top ring has, so we're going to measure this line here, 0.361 inches, and we're going to go back and put that line in. So there we go. Since it is locked vertically, all we have to do is change this to 0.361 inches, and it'll line itself up. There we go. So now we're just going to extrude that through. I'm going to click the remove. And now we have the first hole in our gearbox plate. So just for some convenience, I'm going to round off the edges using the fillet tool, so that way they're not sharp and they don't poke me. It also just makes the piece look more finished. We're going to create a version now, which will allow us to be able to import this into an assembly. You can see here all the different versions. Since V1 is our main, they are both the same. But as you get more, you will be able to scroll through and see all of the different versions you have. Going to create a version of this as well. And go to the Assembly tab at the bottom and insert our plate and our motor. So now that we have the motor, I'm going to group it together to be able to make sure that all of the different parts that are in the motor stay together. Now I'm going to try to line this up as best I can to be able to mate it correctly to the hole that we have placed into the plate. I'm going to grab a fasten mate and place it around the top ring. Make sure I get the very center with the blue line facing up, the direction I want the motor to go, as you can see there. Now I'm going to rotate the plate around and do the same thing. There we go. Now that we've finished tying the motor to the gearbox plate, we can start making our gear. We're going to start out much the same, but this time we're going to start onto the top face and place a circle that we're going to measure out to 3 inches. Now we're going to begin to put the teeth onto the gear. We want the teeth of the gear to stick out so they'll be able to mesh with the other gear in the gearbox, but we also want to round off the corners so they don't bind and get stuck when trying to turn. Sometimes, when I'm trying to move an object, it'll seem to be stuck. The reason why is because when placing a line in OnShape, sometimes it'll constrain itself to another portion of your drawing or your model. So it's important that if it is stuck, to look around and see if there's a binding point. If so, you can remove the constraint and continue on. In this case, the constraint was in the form of the 2 lines with a dot in the center. That means it was attached to a center point somewhere. To be able to center the tooth onto the gear, I used a series of construction lines and measurements. Now, rather than having to place every individual tooth, I'm going to use the linear pattern to be able to revolve them around the circle. I'm going to switch from 3, which is the default, to 10 teeth. And there we go. Now that we're done there, all we have to do is extrude the teeth and the circle. Now that we have finished making the basic gear, it's time to go and put the hole in to be able to mount it to the motor. So what we're going to do is we're going to create a circle in the sketch here, and then go over to the Never-S motor and measure out the top of the shaft. We're then going to go back and we're going to put the measurement into the gear. The reason why I'm putting a flat side on the hole is because the shaft for the motor has a flat side. This will allow it to actually spin the gear instead of just sitting press fit into the hole. Now that I've put the hole in for the shaft, I'm going to create 2 more circles in a sketch, and then fill them in with rectangles to be able to make a cutout into the gear to lighten it up. I'm also going to use the trim tool to remove any edges that I do not want. Now I'm going to use the chamfer and the fillet tool to be able to flush the edges out inside and outside the gear. Normally in OnShape, if actions cannot be done, it'll give you a red error message. In this case, the reason why is because I tried to make a fillet, or chamfer, that was much too large. Now that the first gear is finished, we're going to go back to our assembly and insert it and attach it to the motor. A good way to find the parts that you've recently made is to go to the Other Documents tab and then go down to Recently Opened. When you select a part, there are many options that will appear. A bunch of lines, squares, and circles with lines on them. Using these, you can rotate a part around or move it up and down or side to side. Now that we've done that, it's time to start on the second gear. But first, we need to put a hole into the plate to be able to allow for a secondary shaft to attach the second gear to the first. Instead of making a completely new gear, I'm going to take the old one and resize it and make some minor adjustments to make it work. To be able to realign the gears, I make use of the horizontal tool to be able to set the 2 points on either side of the tooth horizontal. Since they already have a size measurement specified, they will auto-align themselves on the gear. Since I didn't size some of the measurements to the gear itself, I have to go through the sketches and resize them to be able to match the new parts. This is fairly simple and just requires going through the different sketches and changing the measurement. Once again, I use my fillet and my chamfer tool to be able to smooth out the edges and the inside of the gear. All I need to do now is adjust the gears and align them into their place. Once again, instead of having to create a completely new part, I'm going to duplicate the old one and make some minor adjustments to be able to make it fit. Now that we've finished all the parts, all we have to do is assemble them and make sure that they all fit properly in the assembly. When you're using the mate feature, there is an option that you can use called offset. When you are offsetting a piece, it will allow you to change its current position based on the fasten mate. I'm currently doing the Z-axis, which will allow it to go up and down around where it should be fastened. Now, finally, we have a complete and working gearbox that all the work that has to be done is to print it out. Thank you for watching from Team 14615 Turbocharged, and we hope that you all have a great season.